Today, we'll be solving LeetCode 1288, remove covered intervals. This problem gives us a list of intervals. Each interval has a starting point on the left and an ending point on the right. One interval is considered covered by another if its left point is greater than or equal to the other's left, and its right point is less than or equal to the other's right. In simple terms, if one interval is fully inside another, then it is covered and we should remove it. At the end, we return how many intervals remain. Now, how do we approach this problem? Whenever we deal with intervals, a powerful strategy is to sort them first. Sorting puts the intervals in an order that makes it easier to detect coverage. Here's the trick: we sort the intervals by their left value in ascending order. If two intervals start at the same left position, we sort them by their right value in descending order. Why descending for the right value? Because if two intervals start at the same place, the longer one, the one that ends later, should come first. This way, when we process the list, any smaller interval starting at the same point will already be seen as covered. Once sorted, we scan through the intervals. We keep track of the farthest right endpoint we have seen so far. For each interval, if its right endpoint is less than or equal to that farthest right, then this interval must be covered by a previous one, so we ignore it. Otherwise, if its right endpoint is greater, that means this interval is not covered, so we count it and update our farthest right endpoint. Let's now walk line by line through the code to understand it completely. First, we call the sort function on the intervals. We pass in a lambda function as the key. A lambda function in Python is just a quick way to write a small function without naming it. In this case, the lambda function takes an interval, which is a list with two values, and returns a pair consisting of the left value and the negative of the right value. Returning negative of the right flips the order so that a larger right endpoint comes before a smaller one. For example, if two intervals start at the same position, the one that ends farther to the right will appear earlier in the sorted order. This is exactly what we need to detect covered intervals. Next, we create a variable named count and set it to 0. This will hold the number of intervals that remain after removing the covered ones. Then, we create another variable named right and set it to 0. This variable will track the farthest right endpoint we have seen so far. Then we start looping through the sorted intervals. For each interval, we take its start and end values. We only really need the end value for our comparison, but the start comes along with it. Inside the loop, we check if the current end value is greater than right. If it is greater, that means this interval is not covered, so we increase count by 1 and update right to this new end value. If it is not greater, that means the interval is covered by one we saw earlier, so we skip it without increasing the count. After we finish looping through all intervals, we return count, which is the number of uncovered intervals that remain. The time complexity of this solution is O of n log n, because sorting takes n log n time, and the loop through the intervals takes O of n. The space complexity is O of 1, because we only use a few variables. So the key pattern here is greedy with sorting. We sort in a special way to make covered intervals easy to detect, then we greedily keep track of the farthest right endpoint and count only the intervals that extend farther. And that's how you solve LeetCode 1288, remove covered intervals. Thank you for watching and let's keep learning.